Hi everyone, I hope this finds you doing well. A few weeks back, JetBrains released their 2026.1 IDEs, and one of the things that I was most excited to see in that release was that in IntelliJ IDEA, the free version of it, they now provide first-class language support for JavaScript, TypeScript, and CSS. And that's something that if you followed me for any length of time, you know that I've tried to really bridge that gap for people that pair Illuminated Cloud with one of the free JetBrains IDEs, most recently by adding support for the language servers for those languages and for some of the static code analyzers like ESLint and StyleLint and things like that via LSP for IJ, and that's actually worked quite well. But there was still a feature gap between that and the first class support that the commercial IDEs have provided. So again, I was very excited to see this, and I'm going to do a quick demo of that. But one of the things I want to show specifically in this demo is that while they provide support for those languages and for refactoring and for static code analysis and formatters and things like that, the things that were notably missing were Jest test framework support and the JavaScript debugger, which really is more about for Salesforce development, being able to develop and debug your Jest tests. And I've actually closed that gap, and I'm going to show that here. So those parts are going to be, of course, applicable to people that are pairing Illuminated Cloud with the free JetBrains IDE, in this case with IntelliJ IDEA Free Edition 2026.1 or higher. For those of you that are pairing Illuminated Cloud with a commercial IDE, you've already had access to these features. Now, this may provide an opportunity to decide whether you still need a commercial JetBrains IDE, and that's really up to you. I'm not trying to discourage anyone from paying JetBrains for their wonderful product. Obviously, I use it myself. I pay for it. But if you're only doing strictly Salesforce development and it's Apex and Lightning Web Components and metadata, you may not need a commercial JetBrains IDE anymore because Illuminated Cloud with the free version of IntelliJ IDEA may now give everything that you need. If you've been using one of the older free IDEs, what I'm going to show doesn't apply because it needs the new features that were added in 2026.1. But I do encourage you to just upgrade if you're using it with a free IDE to 2026.1 and take advantage of what I'm about to show. Let's go ahead and start with the actual language features, and they're going to be pretty straightforward. I'm not going to spend too much time on them specifically. Things like smart code completion, the ability to bring up the integrated API documentation if it's available, parameter info, the ability to navigate through the code base very easily. We can come over here and we can look for handle first name change, and we can navigate to the usage of that. If I want to, I can rename that, and it will rename across all usages across all languages in which this symbol is represented. If we want to navigate up and down inside this class, it becomes very easy to do so. Structure view. A lot of these things, like I said, were also available through the language server, but let's talk about some things that weren't necessarily. So for example, refactoring. I can certainly begin an extraction refactoring here for a local variable, but we can look at the various refactorings that are available, things like change method signature, introduce constant, parameter field, extracting methods in superclasses, inlining. You can actually pull members up and down inheritance hierarchies, things like that. These are all now available for JavaScript and for TypeScript. If we look at a CSS file, I think I had one over here. Let's see. We can see the same types of things. We can see that you've got code completion for selectors, for values. We can navigate very easily up and down. You can see the gutter swatches for colors and for icons and for things like that. I can navigate to the actual usages of one of these selectors, both in CSS and in styles where they get applied. This is something that again was present when using it with the language server, but I think it's going to be significantly more powerful, significantly more robust using the first class JetBrains language support. And there is very limited refactoring when you're in a CSS file. Obviously, it doesn't have the same types of refactorings available, but things like introducing a CSS variable or things like copying are going to be there. But that's going to be much more extensive when you're dealing with JavaScript or TypeScript. So all those types of features are going to be there. Like I said, the things that are notably missing are going to be around unit test execution, specifically for Lightning Web Components. So for Jest and the ability to execute those, view coverage of those, do interactive debugging of those. So why don't we take a look at how that works? The first thing we want to do is we want to open up the Illuminated Cloud application level settings and go to the LWC tab, and you'll see this unit test area. Now again, you'll only see this if you're an IntelliJ IDEA 2026.1 or higher and it's not licensed, it's the free version. Otherwise, again, you don't need this or you don't have access to this yet. But assuming that you're in that specific configuration, then you're going to see this, and it's going to show you first, do you want this Jest integration? You can turn it off completely, and we can see over here, well, let's go ahead and move over to a test. So we can see like the gutter icons and things like that. Let's open that back up and we can turn that off, and we'll see all that disappear. So those are no longer available. But my guess is, if this is what you're using, you want it available. And so the other options you can configure here are things like, which of the executors do you want? Run, watch, that's going to be your continuous feedback loop for test execution, run with coverage for coverage analysis, interactive debugging. And of course, two of these have some additional options. When you're running it for watch, you can configure your watch type. Jest has two different ways of deciding what subset of tests are going to be run. Watch, which is the default, is going to run only tests that are changed relative to version control, or that have dependencies on things changed relative to version control. That's the default. But if you want it to run all tests, you can say watch all. And the other is whether or not you want deploy on save disabled while you're in this continuous feedback loop, because of course your Jest tests run locally. So if you just want to kind of turn off all interaction with the org, then you can, at least in terms of automatic interaction, if you're hitting Control S, Command S, you can disable this option, or you can enable this option, enabled by default. If you don't like that and always want things to be deployed when you press Control S or Command S, then just disable this option. And then as far as debug, it does use DAP, the debug adapter protocol. It does use that via LSP for IJ. I already have that installed. If you didn't, it would prompt you to install it. And then you need the DAP debugger, the JavaScript DAP debugger. And so if I click this link, it will take me to the latest release of that. I can debug the distribution of it, extract it somewhere in the file system, and point Illuminated Cloud at it. And if you have those prereqs out of the way, let's look at what it looks like. If you're familiar with unit tests in Apex or in other languages, this is going to work very similarly. So first, we can execute tests very easily in different manner and at different contexts by using context actions, context configs. So if I right click on this, I can see a run all Jest tests context option in addition to the one for running all the Apex tests, things like that. But I can see run all Jest tests, and if I click that, it will actually run. Similarly, I can run all under a particular directory. So like run all tests under the specific directory, or if I go to a file, I can run the specific file. If I want to run a specific test suite within a file, I can click in the gutter, or I can bring up the context menu actions using Alt Enter or Opt Enter, depending upon whether you're on Windows, Linux for Opt Enter, or for Alt Enter, or Mac for Opt Enter. If I want to run a contained kind of a sub suite, I can do that. If I want to run one specific test, I can do that. And we can see the actions that are available. They're the same ones that we saw as executors in the configuration. Run, watch, that's the continuous feedback loop, interactive debugging, run with coverage. Now debugging, by the way, is only available at the individual test level. So if I go up to the suite level, you won't see debug. If I look up here at the all Jest test, you can see that debug is disabled. Right now it's only at the individual test level. So why don't we go ahead and execute some tests. Let's just go ahead and execute all Jest tests. So I've now started it. You can see that it's showing all the files that are going to get run. You can see the progress over here. It's executing Jest in the background. We'll look at how it does that. And now that everything's run, in this case everything passed, and so I have this filter so that we don't see past tests. But if I open it up, I can see all the tests. If I want to go double click on one, it'll take me to that specific test. If I want to see the way that it actually executed Jest, I can go to the messages view. I can see Jest. I can see the exact command line that was used from what working directory, how long it took, the exit code, the output, and then standard error. All that gets integrated into the IDE, but if you want to see the options that are being used, you can certainly do so there. And by the way, if you want to add options, you can do that in the run config by going to Jest options and adding them. If you want to change the config file that's used, you can see this is kind of grayed out. It's picked up the Jest config.js from the project root directory, but if I want to change that, I can. If I want to use some other specific Jest config file instead of the one at the project root directory. This is a context config, one that was created by starting with context. So you can see it's read only. If I wanted, I could duplicate this and I could make changes to it, or I could create new Jest run configs right here, and I could set them up at the directory, file, suite, or test level. But again, the easiest way to do that is going to be through context. Just go over here and actually execute it in the context of the actual thing you want to run. So I showed you it running for everything. And by the way, what I didn't show is say a failure. Let's look for an actual test expectation here, and let's change it, and we'll go ahead and just run all tests again, and it's going to run all the tests, and we should see one failure go by. If you watch closely here, in fact it was right at the top there, you'll see the failure, but then it's going to go ahead, and I had that original filter to hide past tests, so now we can see the one failed test, and of course it's hyperlinked to the exact failure, and we can see that right here. We can see the nature of it, and if I revert that, I can now go and say rerun failed tests, and it'll run just that one test. So we can see that one test suite was run, one test within that test suite was run, the other three were skipped because they weren't part of the actual execution. Again, if we go to the messages tool window, we can see there's a much more specific command line in order to filter down to that. What if we want to watch? Let's go over here and let's say we want to watch. So we want to do continuous feedback loop with our Jest tests. And so it's going to run all of them, and we can see that, well, nothing's changed relative to version control. And that's because we're using the watch versus watch all. Now let's go make that same change that we just made. And I'm going to hit Control S, and let's see that two things happen. One, it reruns the tests and we get a failure, and that happens very quickly. We can also see that no deployment actually happened. And then I'm going to go and I'm going to back this out, and we're going to see that it puts things back into a good state very, very, very quickly. Now if I go back over here and change this to watch all, it will instead rerun all tests. Now I'd have to restart this watch because it's running with command line. I would need to rerun it with a new command line. But the point is this gives you the ability to do that continuous feedback loop, and you can break this off into its own, where's the view mode, into its own window, put it on another screen, whatever it is that you want to do. But it gives you the opportunity to have this running in the background while you're working on Jest and working on your LWC components that are actually the system under test. Okay, now let's take a look at running for coverage. So we're going to run all tests for coverage, and it's running all of them. It's actually going to get the coverage. It's going to integrate that into the IDE, and there's going to be more information here than we're accustomed to, for example, with Apex tests, because in addition to having line level coverage, which is what we have with Apex, we also have statement level coverage, which is very similar to line level coverage, but you can't have multiple statements per line. So if we look at it, 1416 versus 1814, there are about 400 additional statements versus lines. So we have some places where you have multiple statements per line. We have functions, whether a function was called or not. We'll look at an example in a moment. And we have branches, literally your subordinate branches that have things to do with like ternary operator and your true and false branches for that, alternation operators, and such. When you OR conditions, which of the ORs, how far in did it get before it short-circuited that OR? And let's look at how this manifests other places in the IDE. So we can see in the project view, it's rolled up along the directory. So we can see, and this is rolled up, by the way, with line level metrics. So we can see that we have line level metrics all the way down to the individual source file in the editor. And I'm going to go ahead and just kind of bring this over real quick. In the editor, let's go to a source file. Close that. Here we go. We can see that we have our traditional, green and red, but this is interesting because here's a statement, but within that we have a ternary operator, and we can see that the ternary operator, the condition evaluated to true, and the true value was used 2 times, and the false value was used 0 times. So this is more detailed than we've had with, for example, Apex code coverage, because we're now getting into the sub-statement level with regard to this coverage, and you see the same thing down here. Now on this one we have our good old green and red, but we also have yellow, and yellow means we have partial coverage. So we have this alternation here in terms of the way that this value gets assessed, and we can see that within it that the left side of the OR actually evaluated 3 times, and so it did not need to actually go to the other side of the OR and use that value, so 0 times. And we'd see that with each of these. Let's look at another example of that. Close that, go to this, and we can see some other things here. So for example, here's an OR where both sides of the OR were evaluated. And the way to read this is, if you know the way that this type of evaluation short-circuiting works, the first expression is going to be evaluated every single time. And if it evaluates to truthy, I think that's the right term, by the way. I'm no JavaScript or TypeScript expert, but in this case, I think if it evaluates so that it can be used, I believe it's called truthy, then it will be used. And we can see that only happened one time, because 5 times the other expression, out of the 6 times this was called, 5 times the other expression was used, and so only one time did this short circuit and return its value. Hopefully that made sense. Let's go down here, and we can see that in this case the true side, basically this expression only evaluated to true 0 times, and every other time, which was every time, it had to use the false evaluation expression. And we have another one down here, I think it's the opposite, that the left side, out of 15 hits, it was able to use the first expression 15 times, and the second expression it never got to, because of course of short circuiting. Hopefully that all makes sense, but the point is there's a lot more information here. If we scroll down, we can also see here's an entire method that was not ever used. And so if we go to GraphQL pagination, we can see here that sure enough, under functions, I said method, but under functions, 10 out of 11 functions were actually covered, and this is the one that was not. So we can see that very clearly. So hopefully that all makes sense. But in other words, all your coverage information is here for you to be able to do good regression suite coverage analysis for your Lightning Web Components and your corresponding tests. All right, let's look at the last thing here, and that's going to be interactive debugging. So let's go over here to something that we'd want to debug. And we'll go ahead and debug this particular test right here. And if I just run this right now, if I just say debug, it's going to run right through to the end, and we're never actually going to begin interactively debugging, because it's not going to stop on the first statement. Now I can set a node arg to do that, but it actually ends up breaking out in the test harness, and that's obviously not very useful. So we're going to go ahead and just set a breakpoint here. In fact, we'll set one here. We'll set a breakpoint here, and I'm going to go ahead and say I want to debug this, and it's going to launch the debugger, and it's going to stop on that first breakpoint. And sure enough, it did, and we can see our call stack. And like I said, if I told it to just stop in Node, not in Jest, to stop at the first executable statement, it would have been way out here, something that we don't care about at all, because that's scaffolding. We can see that we have our call stack. We can see, because of where I set the breakpoint purposefully, we can see that element is already on the call stack. We can go ahead and step down. We can step into flush promises, and we can see that that stack frame has been pushed onto the stack. If I step out, we can see that we're back out now in the original stack frame. Details ELS has now been added to the stack, and we can go and look at the details on it. Interactive debugging. We can evaluate expressions. If I want to say details ELS dot length, and I can see that evaluated. By the way, there is a bug in LSP for IJ. I've just had a PR merged that keeps this from working. Hopefully by the time you even see this, a new release will be out there. But if this isn't working, if you can't bring up the expression evaluator, the next version of LSP for IJ should include my fix for that. So anyways, I think you get the point. Interactive debugging here for JavaScript works just as well for TypeScript. So that's really it, right? That's what I wanted to show. Basically, this is Illuminated Cloud paired with the free version of IntelliJ IDEA 2026.1 or higher, and basically you have all the functionality that you need for Apex, for JavaScript, for TypeScript, for CSS, for Lightning Web Components, for Aura, for Visual Force if you're still using that. Obviously for all the other metadata types, it should be a complete IDE with only the requirement for an Illuminated Cloud license if you're only doing those. Obviously if you're doing Python, if you're doing Ruby, if you're doing PHP, if you're doing Java, and you're needing the enterprise Java level features there, Kotlin, whatever it happens to be, you're going to need a JetBrains license. But if you're using Illuminated Cloud specifically in support of Salesforce development in those languages I mentioned, you should be able to use it with the free version of IntelliJ IDEA and get full support for these languages and these frameworks and these test frameworks, including coverage and interactive debugging and all those types of things. Certainly let me know if you have any issues. Let me know if you find other gaps that I haven't identified, specifically on JavaScript, TypeScript, CSS, that are addressed from the commercial IDEs. And thank you very much for your time. And like I said, take care.